All right, folks, it's Back in action here. In this video, we are going to introduce the double and half angle formulas and then go through a couple examples. There will be a second video that will complete the examples that are on this page, but I'm going to split it between two so that it's not too long of a single video. All right, let's take a look at the formulas that we have up here at the top. I've got them divided between the double angle formulas and the half angle formulas. Now, the double angle formulas, you'll notice that I have boxed off 3 of them. These are the 3 that we're going to use. Cosine actually has 3 versions of its formula, but you can get the remaining 2 versions by using your Pythagorean substitutions. So if you go back to your Pythagorean substitutions in the same way that we did in our solving process, you can replace either the sine squared or the cosine squared and then develop the other 2 formulas. Now, the other thing that I want to point out about these is that instead of trying to memorize these formulas as we go through the examples, I'm going to show you a way that you can basically create these formulas on your own without having to memorize double angle formulas. As opposed to the half angle formulas, we're actually going to provide these formulas for you most of the time. So don't worry too much about trying to get these memorized, but do take some time to jot down these little notes that I've got here. This plus or minus right here, there's a note that I've got here, and it's where the half angle is going to land. You'll see it when we go through an example. If the angle, after it's been divided by 2, so for example, theta over 2, if the sine of that angle, you're doing sine, is in a quadrant where sine is negative, you'll choose the negative. But if the half angle, for example, lands in the first or second quadrant, we'll choose the positive. Again, we're going to go through this through some examples, but do write this note because it's something students get confused about. The theta right here is not this whole angle that you'll be asked to solve. It's just the angle that's being divided. So this theta here will be the same as this theta. So jot that note down as well because, again, students get confused on it. On the tangent half angle, you'll notice that there are 3 versions of this, and I'm going to tell you don't worry about these. Don't scribble them out and get rid of them, but just know that we're not going to really work with these. We're going to keep our focus on this last one because it's going to be the easiest. So let's just jump into an example and see how these formulas are going to work and how we can do them. So you'll need to reference back to those formulas, but I'm going to slide this up here. So the first example that we're going to do is going to be a tangent. So it tells us that our h function is tangent. So you can see over here it's going to be tangent. It tells us we want to do 2a, and our a, they've given us a picture. So the first thing that I want to remind myself is that what I'm essentially doing on this problem is a tangent of an a plus a, because a plus a is 2 times a. This is where I was saying there's an easier way to do this than trying to memorize the formulas. We are going to use our sum formula using the same angle twice to develop our double angle formulas. It'll just be easier for us. Now, on this picture, they've given the equation of the circle. The radius of the circle is going to be the square root of 1. So you can see I've already written that 1 on there. It gave us an ordered pair here of this 1/7. So I've already drawn that. And we need the b value. We're also going to go ahead and put in the right angle that I did not draw in earlier. Now, we've seen this before where this problem looks a little bit complicated here. So essentially what we can do is we can think of this as multiplying each of these values by 7 to clean them up. So if I multiply the 1/7 by 7, I'm going to get a 1 right there. And if I multiply the radius by 7, I'm going to get a 7. So I'm going to turn that 1 into a 7. The other way that we can think about this is we know that we're on a unit circle, and this would represent the cosine. So this would be an adjacent over a hypotenuse, and sure enough, the adjacent becomes 1, and the hypotenuse becomes 7. Either of those strategies will work just fine to get you to this 1 and the 7. Now we're going to do a Pythagorean theorem as we've seen before. If the triangle isn't something from our normal unit circle triangles, we're going to do Pythagorean theorem. If you wanted to jot it down, you certainly could. You would end up with 49 minus 1, and you'd have the square root of that. That's going to give me a negative, because it's in the negative direction, square root of 48, that of course needs to be simplified to a negative 4 square root of 3. Now, to do our double angle formula on this, we can use the sum formula. So writing that out, it's going to look like this. Tangent of A plus tangent of A, remember where the sign matches in the numerator, all over 1 minus tangent A, tangent A. And if you look back at the formulas that we have up here, sure enough, it's the exact same formula, just written a little differently. But we didn't need a special formula. Now we're going to use our picture and we're just going to read our numbers from our picture. So tangent of A, I know I'm going to have 2 of them. Tangent is going to be my opposite over my adjacent, so I'm going to have 2 of this value. So I'm going to have 2 times a negative 4 radical 3. And then that's all going to be over 1 minus. And now I'm going to square this negative 4 radical 3, or I can think of just squaring the negative square root of 48. That'll work just as well for me. So I'm going to square that value. Now if I start cleaning this up, I'm going to have a negative 8 radical 3 in the numerator, and the denominator is going to become 1 minus 48. That, of course, would then become a negative 47 in the denominator and a negative 8 radical 3 in the numerator. And then we would want to reduce. So our final answer is 8 radical 3 over a positive 47. All right, so that's our first problem there, working with our tangent formula. The next one that we're going to do in this video is we're going to look at one where they give us a ratio. We're going to remind ourselves that tangent is, of course, opposite over the adjacent. You can see that I've already drawn my picture and I put it into this third quadrant because the problem told me that it was going to be between pi and 3 pi over 2. Based on that, we of course would finish our radius using our Pythagorean theorem. So we'd have our 2 squared is 4 plus a 1 squared is 1, so that's going to give us a 5. So the hypotenuse is going to be a square root of 5. Now, we want to find the sine of 2 theta. And again, what we're going to think about is we're going to think, hey, this is really no different than sine of a theta plus a theta. So if you don't have the formulas up above memorized, what you can do is you can say sine, cosine, cosine, sine, but this time the angle gets to stay the same. Theta, 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 and theta, and we'll put our plus there in the middle. So now it's easier to be reminded that it's just going to be 2 times this value right here. So we're going to have 2. I'm going to put it over 1. The sine of my angle theta from this picture is going to be my opposite over my hypotenuse. And I'm actually going to write this as a -1, and I'm not going to rationalize. I'm not going to rationalize it because experience tells me that my denominator for these two is going to be the same, so it's going to rationalize this in the process of my solving. My cosine is going to be my adjacent over my hypotenuse. Again, not going to rationalize. I am going to remember to write the negative. And now, when I just multiply straight across, my negatives are going to cancel to a nice positive. I'll get a 4 in the numerator and a 5 in the denominator. So that's going to be my sine 2 theta. The last one that I want to look at is going to be our half angle. So you can see right here, I've written out this new interval. What I did was I took the original interval that was provided for me, this one up here, and my original interval said that theta was on the interval from pi to 3 pi over 2. Well, my problem wants to work with theta over 2. So I take theta and I divide it by 2, and then I have to take each part of the interval and divide those by 2. What that tells me is that the half angle, this angle I'm trying to find, this half angle is between pi over 2 and 3 pi over 4. That means that it's in the second quadrant. Because of that, I know that sine is going to be positive in the second quadrant. So when I have my choice on my formula, and I'm going to write my half angle formula here, I'm going to write 1/2, 1 minus cosine theta. When I have my choice here, my theta doesn't look like a theta there, sorry. When I have my choice of this plus or minus, since sine is positive in the second quadrant, I'm going to choose the positive on my half angle formula. Now, what I need to do is the theta, when I go to substitute into this formula and I want this theta here is the theta from the original picture. So now we're going to go ahead and we're going to substitute that in. So I'm going to have my square root, I'm going to have my 1/2, okay, then I'm going to have my 1 minus the cosine from the picture up above, and here's where I am going to rationalize it. I can refind it, -2 over square root of 5, or I can grab it from right here. Either one is fine, and I'm going to write that as my -2 radical 5 over 5. So I did rationalize that in my head. Now, I want to get common denominators inside this parentheses, and let me extend that square root there. I'm going to put this over 1. I'm going to rewrite this as a 5 over 5. Let's make sure that doesn't look like a 15. Okay, 5 over 5. Now, when I do this, I'm going to pull all this together, and that's going to give me, actually, let me slide this up just a little bit for us. We're going to have our square root still. I'm going to have in my numerator is going to be 5, and I'm going to have minus the negative, so it's going to become a plus. So I'm going to have 5 plus 2 radical 5, and that's all going to be over the new denominator is 10. Now I'm going to split this. Numerator, 5 plus 2 radical 5, all over the square root of 10. Now I'm going to rationalize. So the top and bottom is going to get multiplied by a square root of 10. Now, when I multiply that by a square root of 10, this is the part where students do often struggle on this. The denominator is going to become a 10 because that got rationalized. The numerator is going to have a radical in it, and we are multiplying the radicands. So what I'm multiplying is my 5 plus 2 radical 5 times the 10. That's what I am actually going to multiply to create my new radicand of 50. Oops, hate it when I do that. It's been a while since I made that mistake. There we go. 50, because it was 10 times 5, plus 20 square root of 5. So it takes a lot of practice to keep track of all of these, and you really want to make sure that you do not try to scrunch this into too much space. So I'm going to extend that and give ourselves a little, okay. Don't try to scrunch this into too tiny of a space, or you will lose these little radicals and these little signs.